All right, so this is the calculator part of the Chapter 3 test review. I might have my numbering off a little bit, but we're going to start with our compound interest problems. So remember, first you need to know your two compound interest formulas. For n compoundings, we have this formula. It is to the nt power, not rt. And for continuous compounding, we have this formula. Given an initial investment of $5,500, that's the principal amount, into an account that pays an annual interest rate of 2.25%, that's an R of 0.0225. Answer the following questions. Round dollars to the nearest cent and time or anything else to the nearest three places, 1,000. Find the balance, which is A, in the account after 15 years. There's time. If the interest is compounded semi-annually, n equals 2, quarterly, n equals 4, monthly, there are 12 months in a year, continuously, we're using PERT. All right, so the formula is A equals, I'm just going to set up the first one. So 5,500 times 1 plus R, 0.0225 over N to the N times T. So I'm going to write it down how I'm typing it out. So 2 times T is 15. Now, the only thing that we're going to change in parts A, B, and C is the number that goes in for N. So I want to do that in a different color. All right, so let me split screen over to DESMOS here. So I'm just typing this in, 5,500 times 1 plus 0.0225 over 2 raised to the 2 times 15 power. Remember, if you type into times 15 like that, it will keep dropping the multiplication out of the exponent, which is not what we want. So I like to just use parentheses up there. So rounded to the nearest cent, I'm getting an answer of, with a dollar sign, 7,693.41. Now, the only thing that changes for quarterly is, let me see if I can copy this. The only thing that changes for quarterly is the value of N. Oh, of course, it's going to be complicated. Just trying to make things a little simpler. I guess that didn't really work. Okay, so here's my formula for the second problem. The only thing I'm changing out is now N equals 4. Now, you are not necessarily required to write out the formula every single time. In fact, I'm not going to anymore. I just want to change out, just make sure you do it in both places. That 2 becomes a 4, and so does this 2. Remember, your answers should all be sort of within the same amount. Like if I only changed one of the 4s, my answer changed pretty dramatically. I think it decreased as well. So, pay attention to your answers and make sure that they're in the same ballpark. We've only changed by about $7, it looks like. All right, monthly. So let's see. So I'm deleting the 4, making it a 12. Same up here. So now I'm at $7,705.48. Right? And for continuous, this is a different formula. So 5,500 times e to the r, 0.0225, times t, which is 15. So I'm not going to make a small adjustment there. I'm just going to type a new line. And you are just typing the letter E. And the calculator knows that that's the number E, not a variable. So again, still should be in the same ballpark, 7,707.92. All right, number 40. If the interest in the account is compounded continuously, how long will it take for the initial investment to double? Now, I was given an initial investment, but remember, for these, it doesn't really matter that you're starting with 5,500 if you're just going to double it every time. So I'm just going to set up, instead of A equals, I'm just going to say whatever P was, I want to double it. 2P is equal to the initial investment times E to the RT. Even if I put in 5,500 and 11,000, I'm still going to divide by whatever's in front of the E, and it's going to divide out to 2. So you can put the numbers in if you want, but I don't have to give you an initial investment for a problem like this. Now, at this point, we can solve by graphing, or we can solve by taking the natural log of both sides. I'll show you both ways. So let me just, let's see. So I want to graph y equals 2 and y equals e to the 0.0225t. And I'm just looking for a point of intersection. So you just kind of zoom out of it. Somewhere around here, I clicked over here, but the point showed up right there. Now we're going back to time. We're not talking about dollars. So let's round this to the nearest thousandth, which is 3 decimal places. So that's 30.807 years. What if you're having trouble solving by graphing, or you just don't like doing it that way? Remember, you can say you're going to natural log both sides. So natural log of 2 equals the natural log of e to the 0.0225t. This is an inverse operation that cancels out here. So that it's natural log of 2 equals 0.0225t. So if I type in natural log of 2 divided by 0.0225, I should get the same answer for t. So let's just double check on that. Again, you don't have to do it both ways. I'm just showing you both ways. Yeah, same answer. See? So it doesn't matter to me whether you stop here and solve by graphing. That's my preferred method. Or if you solve algebraically, you should get the same exact answer. I usually solve by graphing, and then if that's proving to be challenging, like sometimes the zooming gets pretty weird, then I switch to algebraic. If the interest is compounded quarterly, how long will it take for the balance to reach 8,000? So here I do need to use the initial investment because we're not just talking about doubling or tripling. So 8,000 is equal to the initial, the principal amount, compounded quarterly. So that's this formula. 1 plus 0.0225 over 4 to the nt to the 4t. Now, I can solve it just like this, or I could divide by 5,500. There are a lot of options here. I could divide by 5,500 and then solve. So let me just try the original. Y equals 8,000. Let's get these old ones off too, by the way. Y equals 8,000 and y equals 5,500 times 1 plus 0.0225 over 4 to the 4t. Now remember, we have y equals 8,000, so it's going to take some zooming here. If you want to manually adjust, by the way, you can go to this wrench and change the y values. I don't do that very often unless I'm really screwed up my window. Here's the point of intersection. So I'm getting t equals 16.699 with an 8 on the side would round to 700. So 16.700. What if I wanted to solve algebraically? This one's not as straightforward as base E because natural logging isn't going to take care of our issue, but let's see. We would still have a calculator, so let me do a bit of calculating here. If you're solving this without graphing, first you would divide. And let's just do that as a fraction. You don't want to round it. So I would say fraction 16 over 11. Okay, so 8,000 divided by 1,500 is 16 over 11. I also want to know what this is. This seems like it's going to be a terminating decimal. Yeah, so again, don't round this, but I'm going to use this number as my base. So let me split screen here, sorry. So this is actually 1.005625 to the 4t power. And the reason I wanted to find that out is because remember, we can log base both sides. We can say, let's use that as our base. Take that log of 16 over 11. And if you take the log of that side, it's going to become 4t. So let me see. To be honest, I'm kind of new to DESMOS with logs. So let me see. Can I log this base of 16 over 11? Let's see if it likes that. It likes that. I'm going to double check to see if that's like an actual correct number. If I do log, by the way, how did I get that underscore? I did shift hyphen to get an underscore. Let me just check something. I know log base 2 of 8 is 3. Okay, yeah. So this is probably right. Or I could double check, is this to the this 16 over 11? Sure is. Okay, anyway, enough checking. This is that log value, and then what are we supposed to do with it? We're supposed to divide it by 4 to solve for t. So see how I got the same answer? 16.700. So you don't have to do that. You could just say, I'm just going to go straight from this line to getting my answer. That's what I recommend. But if for some reason the graphing isn't working for you, or if it were like somehow a non-calculator problem on an AP test, then that's what we would go through and do. All right, let's look at this one. 42. Now we're given a new function. It models the percentage of surface sunlight, f of x, that reaches a depth of x feet beneath the surface of the ocean. What percentage of surface sunlight reaches a depth of 50 feet? Now, I know we're used to saying percents are decimals, right? But think about this. F of 0 would just equal 20. So this is 20% of surface sunlight. So when I want to figure out the percentage, or if I want to set it equal to a percentage, I'm not going to set the equation equal to 0.01. I'm going to set it equal to 1. So anyway, this is just asking me to plug in 50 for x. So f of 50, let's see what that's equal to. I always have to clear, just like when I had a graphing calculator, I liked to clear all of my lines before I started a new one. Here's our model. Here's f of 50. You could also just type in 50 in the exponent up there. Let's round to 3 places. So 5.639 will round up to 640. And again, that's a percent of surface sunlight that's reaching through. All right, and at what depth is 1% of the sunlight visible? So we're setting our function equal to 1. And let's just try to solve by graphing. I already have f of x up here. So let's do y equals 1. And I'm zoomed way out. So let's see. There's a little gray point here. It's not this one. That's just 0, 1. It's this one. So yeah, this is for x. Again, if I just go straight from graphing, I get x is about 118.325 feet is our depth. What if I wanted to solve algebraically? Divide by 20. How do you get rid of a base 0.975? You log base 0.975, both sides. And that would be our answer for x. So let's double check that. So log base shift hyphen, or I'm sure somewhere in here there's a way to like underscore, but shift hyphen is your underscore. 0.975 of 1/20th. Oops. And yeah, the answer is the same thing I got, 118.325. All right, what about this one? The function p of x equals 95 minus 30 log base 2x models the percentage, p of x, of students who can recall important features of a classroom lecture as a function of time, where x represents the number of days since the lecture was given. After how many days will it take for only 50% of the students to recall important features of the lecture? Spoiler alert, I don't think it's going to be very many days. It's just how our brains work. Okay, so let's see. Let's get the formula typed out first, or the function. So p of x equals 95 minus 30 log base 2 of x. Oh, wait, what's wrong? Oops, not minus. P of x, wait, hold on. P of x equals, there we go, 95 minus log base 2 of x, minus 30 log base 2 of x. Again, if we put in if we put in numbers for x like 1, p of 1, because I can't do 0, that's not in the domain, but p of 1 is 95, so that's like 95% of the students remember it. So how long will it take for p of x to equal 50? So I'm just going to graph y equals 50, and we can see it's only 2.828 days. So I need to write something down here. So I need to show 50 equals 95 minus 30 log base 2 of x. And again, if I just solve by graphing, what did I get? I got 2.828. And this is days. What if I were solving algebraically? So I would subtract 95, which is what, negative 45, divide by negative 30. See, I can divide by negative 15 here, so that's 3 over 2. You don't have to reduce because you're using a calculator, but I just think it's easier. How do I do the inverse operation of log base 2? I base 2 both sides. So 2 to the 3 halves is equal to x. Let's just double check that that's the same answer that we get. So 2 to the 3 halves, yep, is 2.828. All right. The half-life of thorium-229 is 7,340 years. How long will it take for the sample of the substance to decay to 20% of its original amount? First off, how do we set up half-life? There's a certain amount. You start with a principal amount. We don't know how much. It's always 1/2 to the t over the half-life. I'll explain that in a minute. This is always the setup. Why is this the setup? Because when you plug the half-life in for t, you end up getting 1/2 to the first power times whatever you started with. So half-life is how long it will take for exactly half of the substance to remain. Now we want to get to 20% of the substance. So whatever we start with, we would take 20% of that. So that just like when we double our interest problem or double our money problems in the interest, we divide by p. And then we're left with 0.2 equals 1/2 to the t over 7,340. Again, I can solve by graphing. The numbers, the t will probably be pretty large on this one. So this one might be hard to solve by graphing. Let's take a look. Sometimes you get so zoomed out that it's hard to see in DESMOS where the intersection point is. So y equals 0.2 and y equals 1/2 to the t over 7,340. Remember, to get to 50%, we have to get out to 7,340. So maybe if I adjust my y values, they certainly don't need to be expanded out. They need to be like between 0 and 1, right, to get to 100%. So that's where using this really does help me. And then, there we go. So yeah, the answer is 17,000. Let me write this down. 17,042.952. 17,042.952 years. If the zooming isn't quite working for you, and again, the reason I went from 0 to 1 here was because, remember, we're just setting this equal to 0.2. So your y window really just needs to capture that y value. If I were solving algebraically, I could log base 1/2 both sides. That would leave me with t over 7,340. And then if I type in multiplying 7,340 times the log base 1/2 of 0.2, I should get the same answer. So solving by graphing is supposed to be convenient. If it's not convenient for you, then you need to go to your algebraic skills, which we should be pretty solid on. We've been solving these for a little while now. So see how I get the same answer? If you ever need to get a reminder on how to type something in to Desmos, like how do I type in the little base thing, just come and ask me. Obviously you can't do that on an AP test, but we'll get to a place where you hopefully remember it by the end of the year. Number 45, the logistic growth function f of t equals this. Describes the number of people who have become ill with influenza 2 weeks after its initial outbreak in a particular community. How many people became ill with the flu when the epidemic began? So began is always time equals 0, and we're going to round to the nearest person, so whole number. All right, so this is just saying, what is f of 0? All right, so f of 0, let me just get the function typed in. I know I'm going to need it for the other parts, although I could do f of 0 and leave it as a fraction if I needed to. Remember, don't type in commas. Desmos will give you an error message for that. And again, if you're getting an error message and you don't understand why during a quiz or test, please come see me. Okay, so here's this, and we want f of 0. To the nearest whole person, that would be 20. So there were originally 20 people that started with this little flu outbreak. How many people were ill by the 4th week? So t is measured in weeks, so that's just f of 4. So let's just trade this out. Put 4 in there. Well, that escalated quickly. 1,080 people. As I struggle with a sinus cold here. Okay, how many weeks will it take for 10,000 people to become ill by the flu? So now we're setting this equation equal to 10,000. I'm going to hope to solve this by graphing, but I will show you how to solve algebraically as well. All right, so, well, maybe. I'm kind of running out of time. Okay, y equals 10,000. Oh, see, it didn't like my comma. Now my window is all like crazy, so I'm zooming way back out here. But where is y is 10,000? Let's make some adjustments here. Again, I'm trying to see y equals 10,000. So let me just go like, how about 8,000 to 11,000? That ought to give me a pretty good window. Yeah, there we go. All right, so time is we're back to time, so 6.320. And this is weeks. I'm going to skip the algebraic solving because I'm getting close to when students will be coming in. The algebraic solving, let me give you the first step, though. It would be 10,000 times the denominator. You got to get the e out of the denominator. And then you're going to divide by 10,000. So that's going to be 10. Okay, now I'm just solving. Subtract 1 and divide by 5,000. So 10 minus 1 is 9, divided by 5,000. And then we're going to natural log both sides. And divide your answer by -1. And that should give you the same answer here. Okay, 46. The data below shows the amount of savings needed for healthcare expenses during retirement compared to the age of death. Using an exponential regression, find the amount of savings needed for a person whose age at death is 87 years. So that's asking me to, let's see, savings needed is the output and age of death is the input. So let's go to DESMOS to add this table. So we go to the plus sign, we add a table, and we put in our values, zooming out so I can see it all at once. Okay, so 80, 85, starts guessing for me. Those inputs are going up by 5, so that's fine. Remember, no commas. 219,000, 307,000, 409,000, 524,000, 656,000. You can zoom fit if you'd like to zoom fit. I like doing that. Add a regression, change it to exponential because it told me that. And here's the equation. I like to paste it into the next line because I'm probably going to have to do something with it. So let's write down the model unrounded first. So that was y equals, again, don't round any of this, times 1.0532 to the x. And this is saying how much savings will be needed for someone who is 87, age of death is 87 years. So that's plugging in 87 in for x. So I'm just going to go, I'm just going to go up here and erase the x and put in an 87, I mean. And so that would be, this is a dollar amount, 339,341.88. 339,341.88. Last question. An experimental population of mosquitoes is growing exponentially. Let's ax that, call it a to the bx. This is also, I originally had that this was non-calculator, but that's not true. The initial population was 100, so we have 0, 100. 4 days later, there were 165 mosquitoes. Show the work to find coefficients A and B without the use of a calc. So ignore that, because now that I know more about the AP test, we will always have this on the calculator part. So I'm just going to come up with the model using regression and yeah, go from there. So let's see. Let's just do all this over again. So add a table. We only have 0 and 4, and we have 100 and 165. Exponential regression. There it is. So it's 100. Y equals 100. That makes sense because when you plug in 0, you get 100 times 1.13337 to the x. So A is 100. B you can round when you're reporting it, 1.133. What if I did have to make it A times e to the bx? You are allowed to write an equation that says, for your regression, y1, instead of equals, use this tilde, which is shift and the little like wavy symbol to the left of the 1, is equal to A times e to the bx. And then x needs a little x1 as well. And so putting in the x1 and y1 uses those values as well. So if I needed that, then it would be a same a value, but it would be a different b value because e to that b gives me the same 1.13337. We'll focus more on that when we prep for the AP test in case it's not a straight regression that DESMOS can do. All right, I hope this gave you more information than you really needed. I'm hoping that you will just solve most of the calculator problems by graphing because that's the most efficient method, and we are, for our AP exam, going for efficiency. But you can also fall back on your algebraic skills for these.